In this video, I'm going to explain you the different types of monoliths that you could find in the IT industry, according to Sam Newman, the author of Monolith to Microservices. In case that you are new to this concept, please remain till the end of the video. I will go in huge detail about all of these topics. And if you have been around the IT industry for a long time, I think that this will benefit you as well. Please remain till the end of the video, as I will leave a type of monolith to the end, explaining my personal experience. So the first type of a monolith that we could find according to Sam Newman is the single process monolith, and it consists of a single unit of deployment. All our code will be deployed at once as a whole, and we will represent that with this box. This box represents our monolith. And this monolith, our code, typically talks to what? To a database, right? We need to interact with data. So this is talking to a database. Just to not overwhelm you, consider this database as a single instance and this monolith as a single instance, right? This type of a monolith is the main one that you will find in the IT industry, right? I would say just making up a percentage, 80% of monoliths belong to that. So the main question is, why is this monolith architecture important? Well, the thing is that there is a huge hype in the IT industry that we need to scale. And we could scale with two ways. So one is scaling up. We mean that we buy more resources, more CPU, more this, whatever, on the machine where this monolith is running. So this is really cost. And then the other way is that it's the hype that is going on right now is scaling this monolith out, which means that we copy this monolith, this single deployment, and we deploy it in another machine and in another machine. So if you do that, you will end up that you need to still talk to this database. And there you go. You will have 3 instances attacking to the database. Where is the bottleneck? Here. Most likely, I predict that here there would be inconsistency in the data because we have 3 spots attacking to the single instance, as well as there would be deadlocks, locking. So all of that would be really overwhelmed. So this scenario is really scary. And people from IT, we think, okay, so before doing that, let's scale out this database, right? So let's make another instance for this guy. And let's make another instance for this guy. Okay, right, I have 3 instances and I have 3 applications. Nice. However, this is scenario, no way. This is not cost effective. With this approach, no way to survive. You have 3 instances of the application running, most likely in 3 different sites. Sites meaning virtual machines, server, I mean bare metal servers, or most likely containers. That would be the best approach if your architecture and your technology allow it. However, on the database, having here 3 instances running, inconsistency will be fatal, because let's imagine that this instance here is updating one record, and at the same time this guy over here is reading from the database. Which instance is going to read? This one, this one, this one, because the record has been updated here, and if he pulls this data here, it would be inconsistent. So forget about this scenario. Now let's move on to a subtype called Modular Monolith, which will forget about all of that and try to figure out something better. Now we are in the initial scenario, and most likely this guy here will follow a layered architecture. For instance, you could check that out. I'll leave you on the description a video I made months ago. And the point here is that most likely, perhaps you could find that this Monolith is a system called ERP, for instance, which stands for Enterprise Resource Planning. And this guy here is responsible that all your departments on your company, sales, purchasing, the warehouse, production, all of them are friends and they see the same information and they are able to see what has happened in a sales order, for instance. So a good approach would be that you could find that you have a module called purchasing. You have another module called sales. You could find another called production. Another one, inventory, which is really nice, right? All of them. Here would be module 3, module 5, module 6, module 7, module 8. And these structure modules are awesome. We love finding these kind of structures. If all the programs are in a cohesive way, meaning that sales programs are in charge just for sales programs and they are not doing many other things related to reports or just sending emails. This could be, for instance, in this module called notifications. We are separating concerns. And these boundaries limit the scope of the programs. So they are in a low coupling. We like having architectures that are low coupled because one part of the system is in charge of sales and the other part is in charge of production. And when I want to change something from sales, most likely I would not have to change that much in production. So from this type of architecture, someone could come up with, okay, so I have this monolith split in different modules. So why not splitting the database in different instances? So I move apart from sales, here sales database, and this guy will talk to sales. If you do this for the entire application, each module with different databases, that would be really, really hard to move. Because moving from one database to different databases, you don't know what's in here. Perhaps there are triggers that are programs that, depending on an event, I create a sales order, and then for whatever reason, I create automatically a purchase order because I need to supply something in order to product whatever product. So this, from my point of view, is not the way that I would go. However, you could find that some companies have moved to this type of approach, and if you are going to that, it would be really hard. If you continue doing this, you will find that here you have a database for the module 6. Look at that. 1, 2, 3. This is going to be traffic in your network. Are you prepared for all of this traffic? I would go with this approach in just cases where you will find this type of a structure. I will maintain that, and then we could see if it's a good approach to go to microservices, which I don't speak in this video. And which benefits bring you a modular monolith? Well, if the boundaries are well respected, meaning we have respected the architecture, we could have team A, which will work on purchasing, and we could have team B, which work on sales, and we could have team C, which works in module A, which could be production. This allows parallel work. I could have team A working on purchasing, B on sales, and the unique point where we could have conflict is where purchasing and sales may have some dependencies there. But apart from that, it will allow you a good rhythm for parallel working. However, if this is the theory, this is the good scenario we would like to have. However, most of the times this is not what is happening, and this is really high coupled, and delivering something in purchasing, meaning changing in sales and then in the inventory, and this will be a completely mess. So this is slowing down your production releases, and you are not being efficient, agile, and all of these kind of things that we like in IT. So it will really slow you down when making changes in the code, and most likely you will change something in one of these modules and you will end up breaking something in production because it's really close, and there would be programs calling to this guy and these sales to the M8 module, and all of these dependencies that you don't see at first glance will appear in production and you will break something, and that's not a good approach. The third party monolith. I'm sure that in your company you have software running which was not developed by your team, as could be the ERP, right? You would have there a vendor and your ERP is running perhaps on the cloud or in-house on a bare metal server. Though the reality is that despite having this perhaps cloud, what's in here? Which type of architecture they have? Which type of database they have? Because some of the ERP vendors, they even hide the type of database, the engine that they are running. MySQL, PostgreSQL, a NoSQL database, MongoDB, Elastic, we don't know. So with lag, you will have your software here. Let's see that we have a good monolith. This has not to be bad. A monolith architecture doesn't mean that it's legacy architecture, because there is some kind of hype in IT that, well, we have a monolith and everybody is trying to avoid the monolith. No, I mean, if I would have to make up a startup, I will go for a monolith, definitely. So we have a good monolith in a good shape. And this is talking to the ERP, which is here inside. Of course, through an API. With lag, because some of them, they don't provide an API and you need to make remote calls. I put this, remote calls. So in that case, if they change something in the new version, this will break. This will break. So this kind of monolith doesn't depend on you. However, it's good to know that having a good vendor provider is important in order that these things do not happen to you. As promised, I led to this moment a type of monolith called distributed monolith. And I will explain it from my own experience, because when I was working for this company, I didn't realize we were working with a distributed monolith. And this is the worst thing ever could happen in your organization, because you were having the trade-offs from a monolith as well from a distributed system, and you are not having benefits from neither of them. So I will explain you the architecture that we had there and how it's hidden between products. And I'm saying products because we were having this type of architecture. So first of all, we have some third party, let's say supplier. And this supplier was providing us information about products. So products. These guys were selling products and they were sending us the information from this product. So we have the first guy and we have another guy here. Supplier 2, and he's sending products as well. So these two suppliers were sending out information to us and we were receiving this in our own service in-house. We were gathering all of this information and we will centralizing where? To a huge database. Kind of SQL, right? Was not SQL, but kind of SQL. And then on top of that, Right, a monolith. So you have here your precious monolith. And the monolith was exploding the data, just querying data, showing to the final users what type of data was, and so on. Which is fine. I don't have any inconvenience with this type of architecture. The problem came when there was another application here. A website. So other type of third party, our customers, were consuming this website and were able to look at the information from these guys, which is really nice. The problem came when this monolith here tried to explode this SQL data and send it to another application. So sorry for that. We were sending information from the SQL to application B, which, by the way, monolith again. So the point being here is that we have monolith 1 and monolith 2. And this application was consumed by these guys too, because they were able to do some things with this data and perform some operations on sales. But the point is the communication between 1 and 2. So this was awful. And that made me realize, making this video, that we were in a distributed system, but monolith ones, because this guy over here was communicating via HTTP all the time, and this guy over there communicating HTTP via HTTP. So we had HTTP on one place and remote procedure calls on the other way. So two types of communication, from communicating from monolith 2 to monolith 1. That was a mess. So that was terrible, because sometimes this monolith, which as well had another SQL here, sometimes this monolith was attacking the SQL as well. So third step, communicating directly to other databases. Which in fact, this is sharing the database. This database was being shared by these two monoliths. So that was chaotic. To sum up, here are some of the clues that will lead you to realize if you are working on a distributed monolith environment. The first one is that you were making RPC calls. Now you have started making HTTP calls, because they are cheap and they are easy to implement, and they are spreading all over your network. So this is a good symptom. The second one, you are sharing a database. So remember, we had an application, we have the other monolith application, and we're sharing sometimes the same database. That smells. And the third one, most likely these two monolith applications are sharing deployments. So your releases, your software releases to production are waiting to each other. You need to coordinate them, because when deploying something in one monolith application into production, perhaps you are causing to break the second one, so you need to coordinate yourself. And most likely you are experiencing delays when releasing to production, because one team in charge of application A has already finished, however, team B already has not finished because whatever reason. So they need to coordinate and your release is delaying. So these are the symptoms. We have arrived to the end of this video. Hopefully you have enjoyed as much as I did doing the content. Hit that like button and that subscribe button if you have not already done it. Thank you and see you in the next time.